Today we're talking about the graphs of trig functions. We're going to focus on the graph of sine today, a little bit of cosine, but we'll introduce the rest of them later. We're going to start by going back to our unit circle, specifically to our unit circle where we wrote the point values or the point coordinates as decimals. Quick reminder that the first value we used the cosine of either the degree measure or the radian measure to get the x coordinate for every point. And we used sine of the degree or the radians to get the second value or y value. So when we put the sine values on the graph, we're just talking those second coordinates. And if you look at the graph more closely, the y-axis looks completely normal. But the x-axis does not. The x-axis is in radian measures. Now, positive radian measures mean, so off to the right, that means that we're going counterclockwise around the circle. Negative radian measures to the left mean that we're going clockwise around the unit circle. So just remember the x-axis is in radians. So if you look at the unit circle, I'm going to use the radian measure and the sine value to create points on my graph. So I'm going to have the point 0, 0, the point pi over 6 and 0.5, pi over 4 and 0.71, and on, pi halves and 1, all the way around my circle. So when I put those on my graph, I had at 0 radians, my sine value is 0. At pi over 2 radians, my sine value is 1. And then I had some values in between. At pi over 6, I was at 0.5. Next, at pi fourths, I was at 0.71. At pi thirds, I was at 0.87. And then at pi halves, I was at 1. It kind of makes its way back down, 0.87, 0.71, and 0.5 until at pi we're back to 0 again. Right? We made our way back down, 0.87, 0.71, 0.5, and then at pi I was back down to 0 on my y value. Then it goes into the negative values, negative 0.5, negative 0.71, negative 0.87, and down to negative 1 at 3 pi halves. So it starts to go into the negative category. So we're going to be down this way until at 3 pi halves, I was down at negative 1. By the time I get back over to 2 pi, right, I start coming up and up and up, and at 2 pi, I'm back at 0 for my sine value. So I'm going to start coming back up. This pattern is going to continue all the way around my unit circle. I can keep going and get bigger radian measures, but when all is said and done, when I get all of it graphed, it gives me what's called a sine wave. This is the graph of the sine function, and it's going to continue on forever in both directions. So the next thing we're going to do is tell you that this is called a periodic function. A periodic function has values that repeat at regular intervals. Those intervals are called cycles. So since this is going to have the same pattern at the same distance each time, that's called a periodic function. So now let's go through some definitions. These will definitely need to go in your notes. First, maximum. Maximum is going to be our highest y value. The highest points of this graph go up to where y is 1. So our maximum is 1. Then minimum, of course, is going to be your lowest y value. The lowest points on this graph are where y is negative 1. So our minimum is negative 1. Then we have something called a midline. If we have a maximum and a minimum, what do you think the midline is going to be? The midline is halfway between the maximum and the minimum. So our midline we write just a little bit differently though. We want to write it as an equation. The equation of a horizontal line is y equals whatever y value it has. Since this one goes through where y is 0, we write y equals 0. Next we have period. Period is the horizontal distance that it takes to complete a full cycle. So we could go from one maximum to the next. We could go from one minimum to the next. Or I could go from one intercept where we're going uphill to the next intercept where we're going uphill. If you look at the horizontal distance, that has a distance from 0 to 2 pi. So we say that our period is 2 pi long. Okay? From negative pi to pi, that's still 2 pi because I come 1, 2 pi's across. So in this case, our period is 2 pi. Next we have frequency. Frequency is actually directly related to the period, right? So it's directly related to the length, but it's telling us how often the function repeats within that length. So in this sine wave, remember our period was 1 over 2 pi. So our frequency then would be, it was 2 pi. So our frequency would be 1 over 2 pi. That means that I have one cycle within every 2 pi. It only repeats once every 2 pi. Next we have amplitude. Amplitude is the vertical distance from the midline to the maximum or the minimum. Remember, distance is always written as a positive number, so it doesn't matter if we're going up or down, amplitude is always going to be a positive number. So our amplitude, if I look at the distance from, remember this x-axis was our midline in this example. I go up 1 to get to a maximum, and I go down 1 to get to a minimum every single time from my midline. So in this case, my amplitude is 1. How about in this example? This is a different kind of sine wave. It just has some different properties thrown in. First of all, what's the maximum? How high is the highest point on this graph? That would be 3. What then is the minimum? How low is the lowest point on this graph? Since this graph goes down to -1 at its lowest point, our minimum is -1. Next, our midline. What horizontal line is halfway between 3 and -1? There's a couple ways to find it. You can eyeball it, or you can average the maximum and the minimum. 3 plus -1 gives you 2, divided by 2 gives you 1. Our midline is the horizontal line at y equals 1. That's halfway between our maximum and our minimum. The amplitude, if we have, let me draw this in, if our midline comes across this way, what's the distance between our midline and a maximum, or between the midline and a minimum? There is a distance of 2 between those objects, so our amplitude is 2. Then the period. Remember, the period is the horizontal distance that it takes to complete a cycle, right, until our graph starts repeating itself again. So in this case, it's not as easy to see, because if I go, let's say, from where x is 0 at 0 radians, if I go up until I reach that same spot in my next repetition, I can't exactly see where that is. So sometimes you have to reason it out. I can go from, say, 0 to 2 pi, right? That's from where I'm almost up at the top to where I'm almost up at the top. So that's the same place, right, in those two cycles. But within those 2 pi radians, I have 3 complete cycles. I have 1, I have 2, and I have 3 complete cycles. It repeats itself 3 times. So within those 2 pi, I can divide that into 3 equal cycles. My period is 2 pi over 3. 2 pi is divided into 3 equal cycles. So it takes 2 pi over 3 radians to complete 1 cycle. Next, let's talk about frequency. Remember, frequency is going to be the reciprocal of the period. So if I turn that fraction upside down, I get 3 over 2 pi. That means that I have 3 full cycles for every 2 pi radians. Now let's quickly look at the general form for a sine function and a cosine function. They are almost identical except for the sine and the cosine. So we have a times the sine of b times x minus c plus d. Same thing with cosine. Make sure that those go in your notes. Those are going to really help us find those properties if I only have an equation with sine or cosine in them. A in both equations stands for amplitude, so my coefficient out front is my amplitude. 2 pi divided by b is the period, so b tells me how many cycles in within every 2 pi radians. Sorry about that. C, the number that's being subtracted from x, is going to be the horizontal shift. Horizontal, remember, goes right or left, so C is going to be how far I go to the right or left. And D is called a vertical shift, so this takes my original sine function and moves it up or down. So let's take a look. Here's a cosine function. Let's find the period, frequency, midline, and amplitude. First of all, remember the form. Okay, we're just going to compare it to the form. The easiest one to find is amplitude, right? The coefficient out front, amplitude is 2. The next one, the period, remember the period was 2 pi divided by b. B is the number, is always going to be the coefficient in front of the x. So b is 4. So 2 pi over 4 is going to be our period, and then I want to reduce that fraction. For every pi radians, I have 2 cycles. Frequency, remember, is the reciprocal of the period. I have 2 cycles for every pi radians. Next, the midline is what's being added at the end, which means when I have a subtract 2, that means my midline is going to be -2. To change that to an equation, I'm just going to simply write y equals -2. So that's all we're going to cover today. Sorry for the length of the video. Write down any questions that you have. We'll cover some of those in class, don't forget to take the online quiz and bring your notes with you to class. Have a great day, and I'll see you later.